Okay, we had started this last class but didn't finish it. We looked at the first example, which looked at adding two functions. The second example looked at subtracting two functions. And if you have graphs, you can multiply two functions. Again, when you multiply two functions, all you are doing is multiplying the y values. And another way of writing this would be like this. I think on last year's exam they even had one that looked like that, and they had different fonts for the x, so that you would know that the one x was times and the other x was an x. I don't like that. I like the dot. The dot I don't mind inside. I like this the best because I think it's the most obvious that you're taking the function f and multiplying by the function g. But we have to be ready for all sorts of notations. So what happens is you take y values from the blue graph, y values from the red graph, and multiply them together. Now, one of the easiest numbers to multiply by is 0, because 0 times anything is 0. So if I look on this graph, the blue graph is equal to 0 here and here. The red graph is equal to 0 here. Well, for this first point where the red graph is 0 and the blue graph is 0, if I multiply my y values, 0 times 0 will be 0. If I go to this other point where the blue graph is 0, it looks like the red graph is at about 1.4. But still, 0 times 1.4 will be 0. Other points you can look on here, you can look for points where the numbers are whole numbers instead of decimals. Sometimes values where things are 1 are easy, because if I know, for example, here, can you see that the y value on the red graph is 1? 1 times anything stays the same, right? So when I take that red value of 1 and multiply by the blue graph, which happens to be at -1, well, 1 times -1 will make -1. Looking on this graph, is there any other points where either the red graph or the blue graph is 1? Well, here's a point where the blue graph is 1. I can't even tell what that x value is, but I know that when I multiply 1 times the whatever's on the red graph, that's where my green point will be, exactly on the red graph. If I try to find another place where both the red graph and the blue graph have nice numbers, I might pick this one here. Okay, can you see that the y value on this point is at 2? And looks like the blue value when x is 4 is 8. And if you multiplied 2 and 8 together, you'd get a point way up here, 4,16 as a value. So even though both the values were nice numbers, when you multiply them together, it might be way off your graph. Now, when we graph this, so it's going to end up looking like that, more or less, based on the points that we have. And when you're multiplying and dividing graphs, you're going to have to do a fair bit of just plotting points and getting an idea what it looks like. One of the things that we're going to take out of this graph is to notice that there are no values less than 0. Okay? Since the red graph only exists when x is bigger than or equal to 0. In other words, the domain of the red graph is only when x is bigger than or equal to 0. The green graph that we just drew here, of course, if you're not using these colors, you'll have to reword this for yourself. The green graph only exists, its domain is the same for x bigger than or equal to 0. So you can't add something when it's not there in the other function. You can't multiply something when it's not there in the other function. You can't subtract something. So you have to base the domain of what your final graph is based on the domain that you start with. But the basic idea for adding, subtracting, multiplying, and dividing is the same. You just take y values and either add them together, subtract them, multiply, or divide them.